Hello guys, my name is Engineer Holiday. I want to talk about scientific unit and measurement. But before we talk about scientific unit and measurement, let us talk about what is what? Physics. What is physics? Now, first of all, physics is coined from the word physics. Physics, a Greek word called physics. And this Greek word means what? It means nature. So the word physics, this one from Greek word, from where? From Greek word called physics, and which means nature. Now, and that is to say, nature is everything around us. So that means physics study everything around us. Then, if you now say physics study everything around us, then what is now physics? Physics is a science of physics is a science of what? Matter and what? Its motion along what, as well as, let me put it that way, as well as what? Space and time. So that means we can say physics is what? The science is a study of the world, or is a science of matter. Matter, when we talk about matter, we are talking about general nature, meaning that matter is anything that has mass and occupies space. Then we are talking about, because we cannot talk about matter without talking about its motion, as well as space and what? Time. Sometimes we say that what? Physics deals with the study of what? Matter, energy, and dynamics. So when we are talking about dynamics, is talking about the study of the motion and force. Something cannot occupy space without energy. So if a matter must occupy space, if a body must occupy space, it means what? It must possess energy. And matter is everything around us. Everything is matter. The nature is matter. You understand that? Because every nature tries to occupy space. Okay, even in human body, the blood that flows, also what? It flows from one point to another. It occupies space. So that is what we want to talk about. Then, if you are talking about the scientific unit, there are two basic words: physical quantities. Physical quantities. For us to what? Measure physics, we use what? What you call a physical what? Quantity. Physical quantity is what we use to quantify everything in physics. And what is a physical quantity? A physical quantity are quantities that can be measurable, or that have what? Measurable physical what? Quantity. The second of that, they are what? Quantity that have what? A measurable what? Physical quantities, and they are what? And with numerical what? Value. Numerical value and units. With numerical value and units. So that is to say, physical quantities are quantities that have measurable physical quantities with numerical values and what? Your numerical value and units. Now, when we talk about numerical value and units, we are talking about two basic quantities with their unit. Now, listen to good. The unit we are talking about, because if you want to look at unit as in a science world, there's what we call the Système International The what? The Système International. This is a Greek word called what? International what? It's called what? International System of what? Of unit. The Système International what? Unit. We can call them what? The International System of Unit, which we call the SI unit. Now, what is an SI unit? It's a unit that is accepted, a standard unit that is accepted by people all over the world. So when we say this is a unit, we are talking about a unit that is agreed and accepted by all scientists in all over the world. So now when we talk about unit, we have explained that, but under physical quantity, so that I can link up with unit, there are two physical quantity in physics. There are two types of what? Physical what? Quantity. Quantity in physics that are measurable quantities in physics. Two physical quantities. There are two types of physical quantity. Now, number one of the quantity is what we call the basic. The basic, which also known as a fundamental. Fundamental what? Quantities. Sometimes slash units. They are what? Two what? Basic quantity. We have the basic, or what we call fundamental quantity. And we have the second one, which we call the derived quantity. Derived quantity. Now, having known these two now, what is what? A basic quantity. Now, a basic quantities are fundamental quantities or unit from which what? Are what? Fundamental what? Units from which what? Which what? Other what? That means from which what? Other what? Units are obtained. From which other derived, let me put other, from which derived what? Units are obtained. So that is what we say. A fundamental unit are what? Or basic unit are fundamental units, or basic quantity are fundamental quantity from which other quantity what? Are derived or are obtained. So that is to say, which other derived unit are obtained. That means we cannot have a derived quantity without having an inbit of what? Basic quantity inside. And there are 7 major type of quantity. In shortcut, let me give you the word metals. The shortcut of what? Of knowing your fundamental quantity is metals. And what does that metals mean? It means M is mass, E is electric current, T is time, and temperature. That T squared there. Then this is what? Amount of substance. And this is length slash what? Luminous intensity. So these are 7 what? Basic fundamental quantities in physics. Now, before I will stop, I want to first of all put them in a tabular form. Let's see them in a tabular form. Let us see their what? The quantity itself, the what? The unit, and the symbol. Let's have it like that. The quantity itself, let's take what? Mass, for example. Let's take mass. Let's have it. 3 line. The quantity, the what? This what? Units. The quantity, the units, and the symbol. So what do we have now? The first thing we are going to have here is what? Let's take what? Mass, for example. Mass is what? The unit is what? Kilogram. And the symbol is small letter kg. Now the next one is what? Electric current. Please take note of that. Follow that meters. That shortcut I gave to you. The second one is electric current. And the unit is what? Ampere. Why the what? The symbol is what? A. Now we have what? The next one is what? Time. Time is what? What is time? Second. The second. Then it's what? Written as what? The symbol is S. You can write it as S. You can say 2 seconds. It means small letter S. You just know. No. The next one, sometimes we write it as this. It's the same thing. So let me put it like this. Now the next one is what? Temperature. The second T is temperature. Now what is the unit of temperature? We have what? We have Fahrenheit, we have Rankine, we have degree Celsius, we have what? Kelvin. The fundamental unit of what? Of temperature is what? Kelvin. Kelvin. That is the fundamental unit of temperature. So what we want to have is what? K. As you. Then the next one is what? Amount of substance. Amount of what? Substance. So what is amount of substance? Amount of substance is measured in what? Candela. And candela, the symbol is what? CD. Now, anytime you are measuring, a unit is measured in what? Or an SI unit is measured in terms of somebody. Maybe it's named after somebody. For example, Farad, they always use capital letter. For example, Joes, they use capital letter. If you want to talk about what? Capital letter. Newton was named after the what? The man called Isaac Newton. We use capital letter to refer to them, to honor them. So when we are talking about what? The candela, we are talking about what? The unit of what? And then let's talk about what? Okay, amount of substance, sorry, it should be measured in mole. The unit is mole, then this one is MOL. Then what about the what? This is A. We have L there. What is L? Length. The first L there is length, which is measured in meter. Then this one is measured in meter. We have what? The symbol as M. Okay. Then we have the last one, which we call the luminous intensity. That's what we're supposed to measure in candela. Sorry for that. Sorry for that. Okay, so in that is this one is the last one, which we call the what? The candela. So candela is CD. So that is the what? The unit what? The fundamental what? Or the basic what? Basic what? Quantities slash what? Units. Quantities slash unit of what? Of the example. And the shortcut I gave you is meters. Don't forget meters. Very important. I've interpreted it. There are 7 in number. 1, 2, 3, 4, 5, 6, 7. So we are going to have what? 7 fundamental what? Unit. 7 fundamental unit of quantities. Now, under physical quantity, we say we also have derived. But before I talk about derived, there's something I need to talk about. Those are basically, but let me talk about derived first. Derived quantity. Derived what? Quantity, so that we can end this part 1 of this class. Now, when we talk about derived quantity, there are several derived quantities, and I want to talk about so many things about them. You understand me? I want to talk about so many things about them. Number 1 is what? The derived quantities. They are what? The table. Then this one will be what? The formula. Talk about the formula. Then you talk about the units. And we talk about the what? The derived what? What? Expressed in what? Expressed in fundamental. Fundamental. So anyone who cannot what give you now because of time will just give you the basic one. Number one is what? We have area. Area is what? Meter what? Length times breadth. Depending if you assume a rectangular shape. If it's square, it's L square. If it's a circular shape, pi square. So the unit is what? Meter square. And the fundamental unit is still what? Meter square. In terms of fundamental unit. We have what they call volume. Volume is length times breadth times height. Meter cube. Meter cube also. We have what they call what? We have what they call surface. Okay, before I give, let me give velocity. Now, velocity and speed have different formula. Velocity is what? Displacement over time, measured in meter per second. Meter per second. While the word speed is what? Distance over what? Time. Now, anytime you talk about over time, you are talking about rates. Rate of displacement is what? Velocity. Rate of distance is what? Speed. What is rate of charge? Correct. What is the rate of acceleration? It is called jerk or jot. What is the rate of momentum? It is called force. What is the rate of momentum? I say it's called what? Force. What is the rate of impulse? It is also called force. What is the rate of energy or work? It is called power. What is the rate of energy or power? It is called work. What is the rate of volume? It is called flow rate. Flow rate is the rate of volume, which is what? Area times velocity. So volume rate in physics actually means volume or that thing divided by time. What is the rate of mass? It is what? Mass rate, which is mass over time. So when we talk about rate, generally speaking, we are talking about something divided by time. So if I talk about rate of acceleration, don't forget is what? Jerk. J-E-R-K. Now, let's go to what? To acceleration. It's a very interesting class which I want you to learn a lot from me. So this one is velocity. Most persons do not understand physics because of the what? The foundation like this. So velocity divided by time is equal to acceleration, which is meter per second square. Now, meter per second square. Actually, in its sense, velocity in magnitude, acceleration in magnitude can be defined as speed over time. But in terms of magnitude and direction, can be defined as velocity over time. You haven't known that velocity is in terms of it's what can be expressed in vector form, while this one can be expressed in magnitude in scalar form. So now we have force. Force is what? Mass times what? Times acceleration. Mass times acceleration, and it's measured in Newton, capital letter Newton. Why we write the capital letter? Because the man that named it, that discovered force, was Isaac Newton. And it's what? In terms of fundamental, it's kg meters what? Per second square. Why? Mass is measured in kg. Acceleration is measured in meter per second. So this one can be written as what? Meter s minus per second. So now we have what they call what? Work. Work. Don't forget, force can be what? Obtuse. It can be gravitational force. It can be electric force. It can generally they have the same Newton. The formula might change, but the basic formula is what? The acceleration can be acceleration to gravity when it's gravitational force, and so forth and so on. What is force times what? Times distance. Now there are familiar what? Units which are what? Energy. Energy is familiar word. We still have moments, although moment and torque are what? Force times perpendicular distance, because moment and torque are vector while work and energy are scalar. So the unit is what? Newton meter, which is simply as what? Kg meter square per second square. Now what about what? Another word called what? Impulse. Impulse or what? Or impulse or momentum. momentum. The two of them are the same in terms of what? The quantities. Force times time is impulse. Momentum is mass times what? Velocity. Now, don't forget the two of them has something equivalent unit called Newton seconds is the same thing as what? Kg meter over second. Now, this is the same units. If you check them, if you derive them, it's what? The same thing. So the two of them will have a fundamental what, or expressive fundamental unit. It's what? Kg meter per second. That is the unit. We have what they call what? We have talked about moment. Power. Power is what? Force times what? Velocity. We can also take power to be work over time. So work over time is correct. That's why we say power is measured in watt. Watt, capital letter W, because it was named after someone. But we can also write it as joules, capital letter J, because J is what? Anytime a unit is named after a person, we write it in a capital letter. That is the rule governing as what? Unit, extra unit per second. So in that case, you want to write it, you can write it as what? Kilogram meter square per second cube. That is it. So now let us talk about what? This thing. We talk about power. Let's talk about EMF. EMF is what? Is equal to power divided by what? By current. And that will be what per ampere. What? EMF or potential difference. Potential difference is equals to what? Power divided by current. And the unit is what? Kilogram meter square per second cube divided by what? Per ampere. Don't forget, per ampere. That is what this one is for power divided by current. That is it. Now, we also have what we call charge. Charge. These are all derived quantity. Charge. We have what they call charge. Please take note of that. This, if you can know all this, it will make it very easy for us. The basic of understanding physics is what? It rests on this particular chapter. Now, the next one we are going to talk about, which is the quantity, the derived quantity. Let me clean this one so that people will not mix it up. That can be clear. So the next one for it is what? Let's talk about what? Charge. The charge is equal, the formula is equal to what? The current times time. Current times time. Don't forget that charge is a derived quantity. It is not fundamental. Charge, electric charge. Electric charge is what? A fundamental, a derived quantity. Why current is what? Fundamental. Charge is a derived, current is what? Fundamental. Then the units. Let me stop you there because time will not permit us. The unit is what? The unit is what? Let's say what? Ampere second. Ampere second or what? Coulomb. Name after somebody called Coulomb. So probably I will stop this video here. I will continue the video in part 2. We still have more formulas to give, which the formula will continue in part 2 of this particular scientific unit and measurement. So thank you very much. Ensure you subscribe because this is a continuation of the next video we are going to release to you. Thank you. God bless you.